I came up with my headphone now. So I think I had a problem with my laptop's microphone. That's why. Thank you, sir. Now I like to start my presentation. There is slight changes in my topic. My topic goes to geological issues in the development of proposed water transfer projects in Nepal Himalayas. And the outline goes in this way. Firstly, talking about the Nepal Himalayas, which was developed 58 million years ago after the collision of two major tectonic plates, that is Eurasian plate and Indian plate. Different sections of the Himalayas were formed, such as while talking from south to north, firstly, the Indo-Gangetic Plain or Tarai Plain and Sub-Himalayas, Lesser Himalayas, Higher Himalayas, and Tibetan Tethys was formed during this collision. In general, the Nepal Himalayas have, in this, in our country, Nepal, there are 12 major basins, 12 major basins that are formed due to the tectonic origin of the Himalayas. And for the use of the water resource of these basins, the government of Nepal has made a nationwide plan for diversion of the water resources in the Himalayas for different purposes like agriculture, electricity, transportation, and recreational purpose. And for this, the study of the geological characters of the Himalayas is very important, and the issues and challenges that may arise during the construction of these projects are to be considered. And for the issues, I have collected the secondaries data and the secondary issues from the papers, which I'm going to present in these presentations. Firstly, while talking about the history of the water transfer history in Nepal Himalayas, is started from 1974. While talking about the water transfer in Nepal, it was started in the Tarai section, that is Butwal Tinau section, as a hydro tunnel, and gradually the interbasin concept was also introduced, and in the lesser Himalayan section, the Melamchi water supply project was introduced as a interbasin water transfer project, which aimed to divert 170 million liters of water from Indravati river basin, the river basin, one of the river basin to Bagmati, especially to fulfill the demand of the Kathmandu Valley drinking water demand. And secondly, the Bheri Bawai diversion multi-purpose project. This is also an interbasin water transfer project, is under construction. The tunnel is already completed, but the dam and other infrastructure is still under construction. This is also interbasin water transfer project in the sub-Himalayan region, that is Siwalik of the Nepal Himalayas. And this also aims to transfer the water from Veri River Basin to Babai River Basin, which transfers 40 meter cubes of water per second for the electricity and for irrigation. And the other proposed inter-basin water transfer projects are Sunkosi Marine, Uttaraganga, Kaligandaki Thinau diversion, and so on. Other few are also there. These are only proposed projects in Himalayas, higher Himalayas, as well as lesser Himalaya and sub-Himalayan projects. For the hydroelectricity, different for the short term, water is diverted in the Himalayas in the different hydropower projects such as Upper Thamakosi, Solududkosi, Kaveli, Khimti, Kaligandaki, and Arun projects. There are other many more which I have not mentioned here. And So after the formation of the Himalayas, river basins were also formed, and in some places there was a scarcity of water, and in some basins there was abundant water. So to balance the river basin water fluence, Nepal government has proposed many projects which I have already mentioned. And the river, while talking about the river basins, there are 12 major river basins in Nepal Himalaya, which covers and which drains about 72% of the monsoon rainfall to the Indo-Gangetic plains, to the different tributaries of the rivers of Nepal Himalayas. Yes, these are the river basins of the Nepal Himalaya that are presented in a map form of Nepal. And from east to west, there are 12 river basins. Now, talking about the geology of the Nepal Himalaya, from south to north. This is the geological section after Harris and Valley that is presented in a planner from south to north sections, which I've already mentioned also. In this, from the south, there is a Tarai plain called Indo-Gangetic plain. And after that, the Siwalik zone, which are a little more higher than higher mountains, and lesser Himalayan, higher Himalayan zone, and Tibetan Tethys zone. And all these zones of the geology are separated by the special thrust. The Indo-Gangetic plain is separated, Indo-Gangetic plain, between Indo-Gangetic plain and Siwalik zone, there is a main frontal thrust or Himalayan frontal thrust. And between Siwalik zone and lesser Himalayan zone, there is main boundary thrust, and between lesser Himalayan zone and higher Himalayan zone, there is main central thrust. And higher Himalayan zone is separated from Tibetan Tethys by South Tibetan Detachment Systems, that is STDS, STDS, which is shown in the general map. Thus, tectonically, also Himalayan zone is Himalayan zone is with different various lithology with a thrust fault system, thrust fault system. So while talking about the Tibetan Tethys zone, the Paleozoic to Mesozoic is sedimentary rocks, especially sedimentary rocks are found, which is exposed in the northernmost part of our country. And the main Himalayan range, especially called higher Himalayan zone, which includes Mount Everest also, that are above 3,000 meter to 8,848 meter, is composed of metamorphic rocks. There are little bit resistant rocks, which consist of gneiss, schist, and phylitic type of rock. And
Saroj, you have 1 minute.
Oh, then after the lesser Himalayan zone, and lesser Himalayan zone consists of phyllite sandstone, limestone, and dolomite, and so on. The sub Himalayan consists of mudstone, sandstone, and conglomerate beds. Okay, now talking about the geological issues in this Himalaya, there are due to the poor rock, highly weathered rock, and stress overloading in the rock mass, influence of the groundwater, and seismic influence, geological hazards, different issues arises in the Himalaya. So I have compiled some issues. This is the headrest tunnel collapse in the Kali Gandaki hydroelectric project. It was a short-term diversion project in which the tunnel was collapsed. Since the water diversion is made through tunnel in the Himalayas, this is the tunnel collapse during the tunnel construction. And this is the in the weathered rock, during the excavation, the degree of weathering is very intense. So there was a collapse during the excavation in cross section of Khimti hydroelectric project. And the fault and thrust zones are very weak. So this collapse is very severe in Himalayan zone. The squeezing, another is tunnel squeezing project problem while construction of tunnel. The tunnel squeezing is due to the high stress in the rock and in the weak rock. These are some examples of Modi and Kaligandaki headrest tunnel squeezing. Another issues is of Himalayan hazard, such as glacial outburst, flooding
So
are
please move
common in
to the conclusion part, Saroj.
Himalaya. Okay, sure. Now, shortly, due to the outbursting, the blockade, landslide, and damage to the projects are also seen. And this is also the landslide in the portals and arid tunnels of the Himalayas. After the earthquake, the dam, this crack is seen in the dams as well. To conclude that, as we see, there is both challenge and opportunities in Himalayas. Large volume of current-bearing water can be used for drinking, irrigation, and hydropower generation is being lost it today. But in order to use it, there are lots of challenges which I have presented shortly. These geological challenges. Thank you, sir.
Okay, Saroj, thank you very much for your successful presentation. And now with this